Hi, so in this lab I have designed and implemented a finite state machine to replicate the Mustang emergency tail light sequence. The goal was to create a system where when the input x is 1, the light cycle through a pattern, and when x is 0, all the lights remain off. So first I have draw the state diagram. So we have used the S0, S1, S2 and S3. So first uh, there will be a 3 digits everywhere, so 000 100 110 11. That's the identical state diagram. Then we have figured out that I used a Moore machine with 4 states. These lights represents the lighting pattern of the tail light. When x equals 1, the system transits in sequence from 000 to 100, and then same with 100 to 110, and after that 111, and then back to 000. When x equals 0, the system stays in the 000 state, which means all lights are off. So I haven't included the transition table, but in the transition table it shows the current state, the input x, and the next state. When x is 1, the system follows the sequence forward, and when x is 0, the system resets or remains at 000. This is the next state table. So here Q2, Q1 and Q0 represent the current state, and Q2 next, Q1 next, Q0 next represents the next state, and this table is used to derive the Boolean equation that we all know. So I have drawn the K maps, and this I have simplified, and for that I have got the equations x Q0 prime and d2 equals to d1 equals to x and q2 and q0 prime, and d0 equals to x q1 q0 prime. So this is how I have made and derived the equations. So we have used we have choose the D flip-flops because they are simpler to implement in Logisim. I don't think that is matter. If I have used a JK flip-flop, there will be more equations, but a simpler equations I would say. And I also used a Moore machine so that the outputs depend only on the current state. I chose a 3-bit state design so that the outputs can directly drive the LED without additionally decoding. So now I will gonna demonstrate the Logisim circuit. So this is the Logisim circuit. So 3D flip-flops, 3 and 1 input X, and there is a like demonstration of the Mustang tail light. And right now the input is off, and when I on the clock there is no change, so it's on 0000 state. When I turn the input on or press the brake, so and I change the clock, so you can see, so there is sequence that we followed: 1 2 3, and all lights are turning off. So the logic gates implement the equations I derived earlier. The clock controls the state transitions. So when x is 0, all lights are off, and when x is 1, the system starts cycling through the states. You can see the sequence 000, 1000, then 110, and then 111, and then it repeats. So for that I have totally used 3D flip-flops, AND gates, clock signals, input switch, LED outputs. So for the discussion questions, should I use counter or FSM? This design can be considered both, I would say. It is a finite state machine because it transits between defined states. It also a counter since it follows a fixed sequence. Thus, a counter is special case of FSM. Design choice, more versus mainly. I choose more machine. Output depends only on the state, simpler and more stable. D versus GK flip-flops. I would choose D flip-flops, easier to implement in the Logisim. Direct mapping from next set equations. 2-bit versus 3-bit. I would choose 3 bits, allow direct LED connection, reducing decoding logistics. Uh, so this lab demonstrate mastery of learning target 90 FSM counter design. Through this lab I learned how to design system using FSM methodology, how to convert state diagram into a logic circuits, the importance of K-map, practical implementation of using Logisim. Conceptually, I know and I understood how real-world systems like automotive lighting can be modeled using digital logic. Practically, I improved my ability to build synchronized circuits, debug state transitions, implemented sequential logic systems, and this knowledge will be useful in the future topics like embedded systems, digital system design, hardware programming. Yeah, I think that's it from my side, and this completes my design and implementation of Mustang tail light finite state machine with asynchronous and asynchronous. So thank you for watching the video.